Hi, welcome to my topic Circuits and Networks. I am Ravikant Mala Joshula and today we are going to deal with superposition theorem. We are going to employ superposition theorem to obtain current, voltage or power through a particular element. Whether we got the right answer or wrong answer, just we are going to cross check whatever the answer we have obtained with mesh analysis and node analysis, such that we are going to conclude that whatever the method you employ in order to find out current, voltage or power, your answer should be always the same. So first we'll start off with the procedure and the definition. Before understanding the procedure, let us start with the definition. So in a linear network containing two or more independent sources, that is voltage or current sources or combination of both, the resultant current or voltage in any branch is the algebraic sum of the currents or voltages caused by each independent sources acting alone, with all other independent sources being replaced meanwhile by their respective internal resistances. So this is the definition of superposition theorem. In order to apply the superposition theorem, we need to note certain important points. That is, if at all we have a voltage source, we can remove it with the help of short circuit. If at all we have a current source, it can be removed with the help of open circuit. And if at all the dependent sources present in any given circuit are not active sources, hence they act as dissipative components. So you need to concentrate on dependent sources regarding this corner. And we have to remember that dependent sources will have zero value when their control voltage or current are zero. So these are the key important notes you should keep in your mind while applying superposition theorem. Then we'll see the procedure. Start with retain one source at a time in the circuit and replace all other sources with their internal resistances. Determine the output, that is voltage or current, wherever it is required due to the single source acting alone. Repeat the above steps for each of the other independent sources which are present in the given circuit. And finally, find the total contributions by adding algebraically all the contributions due to the independent sources. First, let us find the value of current in 6 ohms using superposition theorem. So we are going to find out the value of current in 6 ohms using superposition theorem. Before applying superposition theorem, just witness the number of the sources which are given. There are two sources which are given. One is current source 9 amperes, another is 36 volts. So I am going to make one source active at one time. I'll take the result and finally I'll add up all the results and I'll check whether the branch current which is obtained in 6 ohms, it is the correct value or not. So step 1, assuming 9 amperes active and 36 volts as inactive, therefore I am going to make 36 volts as short circuit as shown in this figure 1a. So 36 volts is shorted over here. When this is shorted, 12 ohms becomes parallel to 6 ohms and therefore we have a parallel circuit of 6 and 12. Whenever you have parallel resistors, we are going to take the help of current division rule to obtain the result in particular branch. So here we have R1 which is 6 ohms. For this we need to apply the current division rule which is given by I1 is equal to I total. Here I total is 9 amperes for this particular case. Multiply by the opposite resistance. For R1 the opposite resistance is R2 and that is why we are going to take 12 ohms as the opposite resistance for 6 ohms. So we know that the value of total current is 9 amperes. So we are going to apply the formula. And here you can see 9 into opposite is 12 divided by the sum of the two resistances, which gives the answer as 6 amperes. If at all required, we can also find the value of current in branch resistance R2 as I2 is equal to 3 amperes. So this is the requirement if at all you want to find out the value of current in 12 ohms. Right now we are interested in 6 amperes because we have to calculate the branch current in R1 which is 6 ohms. So we'll take this equation as 1 because of 9 amperes which is acting alone. We got the current as 6 amperes. This will treat as result 1. Now we are going to apply 36 volts as active and we are going to make 9 amperes as inactive. and this can be done by open circuiting it. When this is open circuited, the 10 ohms which is connected to 9 amperes, it becomes dummy because the one side it is connected and the other side is not connected. Since it is not connected, the current will not flow in 10 ohms. So therefore it is a dummy resistance. Therefore this circuit is further reduced in this fashion. Now whether the value of current it is in 12 ohms or 6 ohms, it is one and the same. So here I2, which is supposed to flow in 6 ohms, it is also flowing in 12 ohms. That is why we have interchanged here 6 and 12 in order to make sure that every student should understand that the current in series circuit remains the same. So whether it is in 6 ohms or 12 ohms, this is the same answer. So with this we'll get the value of current. I2 is equal to total voltage by total resistance. So 36 by 18. 6 plus 12 will be 18. So this will give you the answer as 2 amperes. So whether we are employing 36 volts, we got the current in 6 ohms, it is 2 amperes. Whether it is in 12 ohms or 6 ohms, the same current. So this will take as result 2. And according to the definition of superposition theorem, we have to add the two cases because there are two sources. So I is equal to I1 plus I2. So which will give you the value as 8 amperes. So this is how we employ the superposition theorem, and we got the answer as 8 amperes. Now let us cross check our answer with any other technique. So here I am going to apply mesh analysis and later on node analysis to cross check my result, which I got as 8 amperes using superposition theorem. So let us apply the mesh analysis. For mesh analysis, I am taking loop 1 and loop 2 direction of the currents in clockwise and anti-clockwise direction respectively. So IA is in clockwise, IB is in anti-clockwise. Now I will be branch current I will be the combination of IA plus IB. So this is one way to find out the answer. And IA, fortunately, the given direction of the current, that is 9 amperes, the branch current, and the loop current, they are one and the same. So I am treating IA as 9 amperes directly by looking into the network. Then I am applying the KVL to the second loop. So I will start off with minus 36 volts. So minus 36 volts is the given voltage. Then 12 into IB, it is a drop across 12 ohms. Then I have 6, it is 6, it is having the current IA and IB acting at the same time. So 6 IB plus IA is equal to 0. This IA plus IB, because the direction of the branch current and the loop currents are one and the same, that's why it is here plus. With this I'll get the value of current IB as minus 1 ampere. So overall, if at all I want to know the value of current that is in 6 ohm, that is a branch current, I'll be getting as 9 plus IB. IB is minus 1, so 9 minus 1, which is equal to 8 amperes. So we can see here I got the same result as 8 amperes, which I have got using superposition theorem. Let us also calculate the value of branch current 6 ohms with the help of node analysis. For that, I have identified a node voltage B, and it is assumed to be at higher potential. So the current is supposed to flow away from this node because it's a higher potential, I am assuming. And I'm going to apply KCL, that is algebraic sum of the currents at a particular node, it is equal to 0. So minus 9 is the branch current which is flowing in this 10 ohms, and it is directed towards the node, that's why I am taking it as minus. And I, it is flowing away from the node V, so that is why V by 6. V by 6 is nothing but, because of Ohm's law, we can say that I is equal to V by 6, and that is another branch current here. And another branch current, it is through 12, so V minus 36 by 12. So that is the current which is flowing in this particular branch, is equivalent to 0. With this I'll get the value of voltage as 48 volts. Once I'm getting the value as 48 volts, now I can easily get the value of current in 6 ohms by dividing this voltage with 6 ohms. So this also gives the answer as 8 amperes. So you can see from the results, superposition theorem, or you apply mesh analysis, or you apply node analysis, or any other circuit property, you are supposed to get the same amount of current which is supposed to be flown in that particular branch, or across voltage across a particular branch which you are going to be measured. So the resultant should always match. Let us find out the value of current in 8 ohms using superposition theorem for this circuit shown in figure 2. Now the same circuit here, you can see here we have 8, 12 and 30. It's pi kind of network. So we have 5 amperes as one active source, 25 amperes as another active source. So we are going to make one source active at one time. So I'm starting with 5 amperes. 5 amperes is active, 25 amperes is inactive. So when this is inactive, this is how the circuits look alike. Now you can see 12 ohms is in parallel with series combination of 8 with 30. So with this, I'm going to apply the current division rule. So I'm going to apply current division rule. So current across 8 ohms or current across 30 ohms will be one and the same because it's a series circuit. So which is equal to total current, that is 5 amperes from this side is coming, and 12 is the opposite resistance, which is opposite to 8 in series with 30, whole divided by the sum of the total resistances, which is nothing but 8 plus 30 plus 12. So this will give you the answer as 1.2 amperes. So with 5 amperes as active, I got the result as 1.2 amperes. I am making as resultant 1. Later on I have to take the help of superposition theorem and I'll sum up all the equations to obtain the final result. Now step 2, 25 amperes I am going to make active and 5 amperes I am going to inactive, and 5 amperes can be made into inactive by open circuiting it. So this is what is done here. You can see the direction of the current, which is flowing in 8 ohms. It is in this direction, and the source current here 25 amperes, it is acting downward direction, and I have to find out the value of current in this direction, which is the current in 8 ohms or in 12 ohms. Now in this case they are one and the same. So I'm going to apply the total branch current, that is I across 8 ohm is equal to minus 25 amperes. It is the source current which is acting opposite to this direction of the current, divided by the opposite resistance. For 8 in series with 12, the opposite is 30, so that is why it is 30, whole divided by 8 plus 30 plus 12. So this will give you the answer as minus 15 amperes. Now this will take as resultant 2. Resultant 1 we got 1.2. So I8, so resultant 1 minus resultant 2. Why minus? Because here the direction of the current, which is shown in black arrow, it is opposite to the blue arrow. So that is why it is minus here. So what that we got as 1.2 from equation 1 minus, and the value of current, which is minus 15 amperes, because of 25 amperes acting in the opposite direction, we got as negative. So overall this current will be 16.2 amperes. So this is what we have done using superposition theorem. Let us cross check the answer with mesh analysis. With mesh analysis, what I can do, I'll apply 3 mesh circuits like this: I1, I2, I3, all are assumed to be as clockwise direction. So I1 loop current and the source current 5 amperes are one and the same, so I1 is equal to 5 amperes. Similarly, observe here I3, the loop current I3 and the source current 25 amperes are in the same direction, so that's why also equal to 25 amperes. So once we get the value of I1 and I3, I'll concentrate on loop 2. So applying mesh analysis to the loop 2, the interloop. So 12, I'm starting with this drop, 12 I2 minus I1 plus 8 I2 plus 30 I2 minus I3 equal to 0. With this I'm going to get the value of I2 as 16.2 amperes. So you can see the result 16.2 amperes. We got the same using superposition theorem. Now also cross check the result with node analysis. So for this I have identified node 1 and node 2. So I am going to apply node analysis at node 1 and node 2 respectively like this. So you can see minus 5 amperes it is coming towards it. So minus 5 plus V1 by 12 plus V1 minus V2 by 8 is equal to 0. So this is one node equation. I am taking that node equation as 3. Another node analysis I am going to apply at node 2. So for this, V2 is I had potential. So V2 minus V1 by 8 is one branch current. V2 by 30 is another branch current, plus 25 amperes because it is outgoing from this particular node is equal to 0. So this we are going to apply like this. So 25, the outgoing branch current, plus V2 by 30 plus V2 minus V1 by 8 is equal to 0. So this we are treating as equation 4. Let us rearrange equation 3 and equation 4 in this fashion. So I am simplifying these two equations and I am going to find out V1 and V2. So V1 we have obtained as minus 135.44 volts and V2 we have obtained as minus 265.38 volts. Once we obtain the value of V1 and V2, we can get the value of current in branch 8 ohms, which is V1 minus V2 by 8. So V1 minus V2 by 8, so minus 135.44 plus 265.38 divided by 8 will give you the value as 16.2 amperes. So you can see whether we employ superposition theorem, mesh analysis or node analysis, we got the same current. The resultant current is one and the same. So we have seen these examples and we have applied 2 to 3 different methods to find out the current conditions. Now in this particular problem, I will be finding out the voltage drop in 3 ohms directly with superposition theorem. As an exercise, you can cross check the result with mesh analysis and node analysis. So let us start with the problem. You can see we have 4 volts, 5 amperes, 15 amperes, 3 sources, and the rest of the resistors are passive elements. So we need to find out the voltage in 3 ohms. Okay, so let's start with the problem. So first I am making active 4 volts. So 4 volts is active and current sources are inactive. So 15 amperes and 5 amperes are deactivated and they are removed. When they are removed, you are going to see these 2 loops are formed like this. Now with these 2 loops, you can see I can apply KVL to these 2 loops to get the result. So I am applying KVL to loop 1 for this particular loop in this direction. So it will start with -4, and loop 2 direction also it is taken in clockwise. So the branch which is having 7 ohms and 5 ohms will have the drop as I1 difference I2. Okay, so -4 plus 2I1, -4 is starting from here, plus 2I1 plus 7, this 7, it is I1 minus I2, plus 5, I1 minus I2 is equal to 0. Here you also have to take the 3 ohms into the consideration. So don't forget to take the value of 3 ohms here. So overall we have taken the value. We are going to get 17 I1 minus 12 I2. How you got 17? You can see you have 2 plus 3. 2 plus 3 will be 5. Okay, and this is all another resistance 5. So 2, 7, 5, 3 will give you the value as 17. Here in this particular equation, 3 ohms is missed. So overall it is considered and we got the same result. You can cross check by applying mesh analysis in a proper way. So we will be getting as 17 I1 minus 12 I2 is equal to 4. This is equation 1. Okay, so don't forget to take this 3 ohms into the consideration by applying mesh analysis. Okay, now let us apply KVL to the loop 2. Here this is the loop 2. So loop 2 I am starting with 9 I2 plus 5, this 5, I2 minus I1 plus 7, I2 minus I1 is equal to 0. So with this I am going to get the equation as minus 12 I1 plus 21 I2 is equal to 0. Just solve for equation 1 and 2 with the help of calculator. We are going to get the value of I1 as 0.3943 amperes and I2 is equal to 0.2253 amperes. So with this we got one result. Now we have to see what is the result we are going to obtain for 3 ohms when 15 amperes is active. So step 2, 15 amperes is active, 5 amperes and 4 volts are inactive. So 4 volts is shorted and another 5 amperes it is removed. So applying KVL to loop 1. So loop 1, loop 2, loop 3 I am identifying here. So I am going to apply KVL to loop 1. So similarly you have 2 I1 plus 7 I1 minus I2, 7 I1 minus I2 plus 5 I1 minus I3. You have to remember that plus 3 I1 is equal to 0, plus 3 I1 is equal to 0. So overall you will be getting the value as, again you can see 2 plus 7 it is 9 plus 5 it will be 14 plus 3 it will be 17. So 17 I1 minus 7 I2 minus 5 I3 is equal to 0. This I am taking as equation 5. Applying KVL to loop 2 and loop 3 at the same time, you can see here 15 amperes is the current source shared by loop 2 and loop 3, so it becomes a super mesh. I am taking the I3 minus I2 because 15 amperes and the direction of the loop current I3 are one and the same, whereas I2 direction, loop current I2 direction and the given 15 amperes are in opposite. So I am taking I3 minus I2 is equal to 15. I am treating as equation 6. Now combining all the elements of the super mesh, that is the rest of the elements which are connected to this super mesh equation. So I am going to collect 7, 9, 5 together and I will apply the overall super mesh analysis. So this super mesh will give you 9I2 at this branch current, sorry at this branch voltage. Then we are going to come at 5. So 5 is there here. So I3 minus I1, this particular case, this is the drop over here. Then you are going to come across 7. 7, it is I2 minus I1 is equal to 0. So with this I am going to get minus 12 I1 plus 6 I2 plus 5 I3 is equal to 0. So this is another equation. So solving equation 5, 6, 7, I am going to get the value of I1 is equal to 3.16, I2 is equal to minus 1.76, I3 is equal to 13.23. Remember, we need to concentrate on 3.16 amperes. So I am taking these equations as numbers 8, 9, 10, and finally I am making this active source 5 amperes as active and 4 volts as well as 15 amperes I am removing VO here. Here also it forms a super mesh. So I am going to apply KVL to loop 3 first. So I am going to get 9 I3 plus 5, I3 minus I1 plus 7 I3 minus I2 equal to 0. And I am going to get the value as minus 5 I1 minus 7 I2 plus 21 I3 is equal to 0. Now this is the equation 11. And I am going to apply KVL to loop 1 and loop 2. Loop I am considering like this, loop 2 over here. So with this, I2 minus I1 is equal to 5 amperes. So that becomes a super mesh. So I2 minus I1 is equal to 5 amperes. And I am going to combine all the rest of the elements of this super mesh. So the rest of the element of the super mesh will give you as 2I2 plus 7, I2 minus I3 plus 5, I1 minus I3 plus 3 I1. Here it is not missed. If at all you observe carefully, it is not missed here. It is considered here carefully. And overall I am going to get the value of 8 I1 plus 9 I2 minus 12 I3 is equal to 0. So this I am treating as equation 13. So I am simplifying equation 11, 12, 13 will give you the equations as I1 is equal to minus 2.46, I2 is equal to 2.53, I3 is equal to 0.258 amperes. So 3 individual cases we have selected. So 3 cases you can see. We got the value of, for the first case, I is equal to 0.3943 amperes. So when we have activated 15 amperes, we got the value of current in 3 ohms as 3.16 amperes. And for the final loop, when you have taken 5 amperes as active, we got the value of current in 3 ohms as minus 2.46 amperes. So this is the important consideration you need to consider. So we have to sum up all these values to get the final current. So equation 3 plus equation 8 plus equation 14 over the results of the branch currents which is flowing in 3 ohms I am going to collect, and I am going to getting the value as 1.0903 amperes. So this is the branch current I got here. Now I am going to get the value of voltage according to Ohm's law. It is resistance into current. So resistance, branch resistance is 3 and the branch current is 1.0903 amperes. With this, the value of voltage it is obtained to be 3.27 volts. So this is how we solve the problems using superposition theorem. You can cross-check the result with the help of mesh analysis or node analysis or any other methods present in circuits, and make sure that you are going to get the same result. In the next class, I am going to deal with the superposition theorem, especially involved with dependent sources. So if you like my video of mesh analysis, node analysis with superposition theorem, you please like it, share it among your friends, subscribe to my channel, and please press the bell icon for the future notifications. Thank you.